or we can also call it hydrocarbon. So I'll be sharing my screen so that we can go straight without wasting time. All right, so let me just quickly share my screen now. In just a minute to share my screen. Okay, I think my screen is displaying now. Okay, so organic chemistry. So this is the class on organic chemistry. Okay, so in this class, we will be learning the following. So in case I'm too fast, you can pause or you can rewind. So in this class, we'll be learning the following. We'll be learning the following learning objectives. Okay, so we'll be learning the meaning of organic chemistry, the meaning of hydrocarbon. We'll be learning about a family of organic chemistry, called alkane, naming of alkanes. We'll be also learning about alkenes, okay, reactions of alkenes, and then we will also learn about alcohol, reaction of alcohol. So if time will permit us, we will also extend it to carboxylic acid, and then we round it up with ester. Now let's start with the meaning of organic chemistry. Look at the meaning on the board. Organic chemistry is actually the study of carbon compound in plants or animal, not carbon compound that you can see anywhere. So the word organic simply means it has to be either in plants or animal. So organic compound. Organic chemistry simply means the study of carbon compound. Okay, all right. So we go on again. There are terminologies we need to know under this topic of organic chemistry. So let's go to one of the terminologies. Okay, look at this terminology now. We have here straight chain. Why do we call it straight chain? Okay, straight chain. Trying to reply. What's the meaning of straight chain? When carbon are joined together in a straight line like this, we call it straight chain hydrocarbon. Now this black dot represents carbon. So that's a straight chain. Then what do we call branch chain? Branch chain is when a straight chain hydrocarbon has a branch. Like this example now is a branch. So this is a straight chain hydrocarbon, carbon. And then we have one, just like a tree has different branches. Okay? So we have a branch of one carbon here. Then what we say ring shape. So when the carbon are connected almost in a circle, we call it ring shape. So that's one terminology. Okay, now in another terminology, there's what we call single bond and double bond. This one is single bond. The carbon connects to another carbon just with one line. We call it single bond. While this one is double bond, the carbon connects to each other because the carbon have like 3 lines. So we are still on terminology carbon, we are still on terminology. Okay, now a family of compounds which have formula. Now look at this terminology again. There's a terminology we are looking at now, homologous series. I want you to look at this. I want us to look at this terminology, homologous series. Just as I mentioned some terminology, straight chain, branch chain, single bond, double bond, triple bond. Homologous series is also a terminology. Now, what is homologous series? Homologous series is actually a family of hydrocarbon, or you can say, in fact, sometimes we use hydrocarbon and organic chemistry. We use hydrocarbon and organic compound interchangeably. Hydrocarbon and organic compound interchangeably. However, we have some differences. Okay, in this case, let's use hydrocarbon. Hydrocarbon is more appropriate. So for homologous series, it means that hydrocarbons that have the same general formula and similar chemical properties. So we use this to define homologous series. Homologous series is a family of hydrocarbon, or you can say that it is a family of organic compound. So when we say family are separated by surname. Okay. So we have the family of opossum, we have another family of maybe Arige family. So you see family are separated by surname. So family of hydrocarbons, that is what we refer to as homologous series. And guess what? For our class, we'll be looking at not up to 5 family of hydrocarbons. We are going to be looking at alkane, the one that has single bond. We are going to be looking at alkane. Please take note of the spelling. The first one ends with A-N-E. That's another family. We are going to be looking at alkanol, or you call it alcohol. Let me write alcohol. That's number 3. Number 4, we are going to be looking at carboxylic acid. Carboxylic acid. And then the last one the family of Esther. It's not the same Esther you spell when you are calling somebody's name. This is the Esther we are talking about. So we are looking at these 5 families. Now, family are called homologous series. Homologous series. So we are going to study these 5 families. So we'll start with the first one. Now, this family has a general formula. Do not forget, homologous series, a family of hydrocarbon that have the same general formula. Look at the same general formula, and they have the same chemical property. Now, for family of alkane now, look at the general formula of alkane. Now, with that general formula, we can write all the members of alkane. All the members of that family, we can name them using this general formula. And then alkenes again. Okay, alkenes. This is the general formula for alkenes. General formula for alkenes. Okay, so for alkenes, we can name all the members of alkenes using this formula. Okay, in a short while, I will tell you how to use this formula. But let us talk about alkanes. Let's talk about alkanes now. Okay, we'll go to alkanes. Yeah, this is alkanes. Now, alkanes are called saturated hydrocarbon. What did I say? Alkanes are called saturated hydrocarbon. Now, why do we call them saturated hydrocarbon? Because the bond between carbon to carbon in alkane is single bond. So, in other words, we will say that saturated hydrocarbon, they are hydrocarbon that have just single bond. So do not forget, the formula for alkane is CnH2n plus 2. Now, from this formula, let us derive the first member of alkane. That is when n equals to 1. When n equals to 1, so wherever you see n, put 1 there. So Cn becomes C1, then H2n becomes 2 times 1, that's 2, then plus another 2, that's 4. So in other words, the first member of alkane is CH4. Now CH4 has a name, we call it methane, or you say methane. Now, the naming of hydrocarbon follow the pattern of, I think, Greek way of numbering. Now, what do I mean? Met means 1, et means 2, 4 means 3, but PUT means 4, pent, like when you have pentagon now, pentagon means 5, pent means 5, and then hex, when you have hexagon, hex means 6. So this is equal suffix now, or prefix. Now this prefix, the letter that starts a word, you just add ane to it to form the member of your alkane family. Like met, because it is one carbon hydrocarbon, met, by the time we add ane, it becomes methane. So we say that is one carbon hydrocarbon. Two carbon hydrocarbon. Just put your ane, it becomes ethane. So that is how we name alkane family. Now, very, very important. Let us see where we can get alkane from. Let's see where we can get alkane from. Now, I will have to take you back to fractional distillation now. Fractional distillation. Now, a very good source of hydrocarbon is crude oil. Now, when we say crude oil, excuse me, let me get my board now. When we say crude oil, we are talking about exclusive oil that when you do fractional distillation of it, you get a lot of products, useful products. Now, crude oil is a very rich source of hydrocarbon or organic compound, because it can ask you give example of sources of hydrocarbon. So when you ask give sources of hydrocarbon, crude oil can be mentioned. Aside crude oil, you can as well mention natural gas. Okay, so let me quickly give you the breakdown of how hydrocarbon is got. Okay, so when you have your crude oil, I'm going to draw now. I hope you can still see my screen. So when you have your crude oil now, which is very rich in hydrocarbon, when you have your crude oil, you take your crude oil to a fractional distillating column that looks like this. Okay, it looks like this. Okay, let me draw it properly now. It looks like this. So we have the first outlet, we have the second outlet, okay, and diagram may not be very fast. Second outlet, third outlet, fourth outlet, fifth outlet. Now this is fractional distillating column. Fractional distillating column, where you refine crude oil. Now when you put your crude oil inside this place, the first product that you get is natural gas. Natural gas. Why are you getting natural gas as the first product? Because it has the lowest melting point and it has the lowest number of hydrocarbon. Now the carbon here is between 1 to 5. So that is where we get alkane, methane, butane. So natural gas is very rich in alkane family. Alkane family. Now after natural gas, what else do we get? After natural gas, we get naphtha. Naphtha. Now naphtha. After naphtha, you get kerosene. After kerosene, you get gasoline. Gasoline is same thing as a petrol. Get petrol. After that, after petrol, you get lubricating oil, lubricating oil, and then the last one you always get is bitumen. Now these are arranged according to their number of carbon that is present. So this is fractional distillation column. Please, this is very important. A note on this has been sent on team already. Please study that note, because for your exam and test, you'll be asked to name the first 5 fractions of fractional distillation of crude oil. Okay, now let's go back to alkane, naming of alkane. Now, going back to naming of alkane, naming of alkane. Now, we want to name alkane, like I said, methane. How do we name methane now? Like I said, now. So how do we name methane? Because it is one carbon, we say methane, and then we put ANE there, becomes methane. How do we name ethane? Ethane. Because the carbon is 2, becomes eth. So ethane. Same like that to propane. And we continue like that until we get C10. Guess what C10 will be? A shape with 10 sides. 10 sides is called decagon. So you can also call this one decane. That is C10H22. That's decane. So after knowing the name of alkane family, the next thing is to know their reaction. Alkane family have how many reactions? Okay, now this is the structure of methane. This is the structure of methane. Carbon has 4 binding sites. When you write carbon like this, carbon can bind at the top with hydrogen. It can bind at the bottom with hydrogen. It can bind at the back, by the left and by the right. So the binding site of carbon is always 4. Take note of that. Now we have methane. It binds to 4 hydrogen. 4 hydrogen. Now ethane bind with 6 hydrogen. 1, 2, 3, 4, 5, 6 hydrogen. Now this carbon has 4 binding sites. 1, 2, 3, 4. Complete. The same second carbon too bind with 4 binding sites. 1, 2, 3, and one at the back, 4. So always maintain that carbon has 4 binding sites. So whichever one you are drawing, make sure you draw them very well. At least learn how to draw a straight chain. Alright, so that is the structure of what? Of alkane family. Members of alkane family. Methane, ethane, propane. So you can take it beyond this. Draw up to 10 for methane, 10. Like I said, a note is given on this already on C. Alright. So we call this display structure. Now this one is called molecular formula. The one that starts with CH4, molecular formula. This one is called display formula. Display formula, where you show the bonds, called display formula. A formula that shows the bonds. However, we have what's called structural formula. Okay, that structural formula, you do not really need that. Just know the molecular formula and the display formula. Now let's go on. Alkane family can be drawn in different ways. These are all the same structure. All these structures, they are the same. Now, for you to be sure of that, count the number of carbon there. This is 1, 2, 3, 4. Let's count this one too. 1, 2, 3, 4. Let's count this one too. 1, 2, 3, 4. So they are the same. They have the same molecular formula. Let me use that one. They have the same molecular formula, which is C4H10. They have the same molecular formula. C4H10. Now, but the structure are drawn differently. Like this one is drawn in a straight chain. The carbon are arranged, by the side. Why this one? The carbon has 1 branch here. This is 1 branch. Why this one? The carbon has 2 branches. This is a straight 1, 2, and this is 1 branch. This is another branch. Okay? Alright. Now, when you have hydrocarbon, please listen to this. When you have hydrocarbon that has the same molecular formula, but different structural formula. Like this one has 3 structural formula. We call that process isomerism. Let me write it here. Isomerism. I hope you can see my handwriting here. Isomerism is the process whereby organic compound or hydrocarbon have the same molecular formula but different structural formula. So we call that isomerism. That is what you have seen on the board now. Okay? And each molecule, each structure is called isomer. So how many isomers are there in C5H12? You can work that out. C5H12. C5H12 has three isomers, 1, 2, 3. Okay, now let's go to properties of alkane now. Properties of alkane, these are physical property. Okay, so as you find the alkane family, boiling point increase, viscosity increase, flammability reduce as you move down. The first member is highly flammable. It is always used as fuel. Natural gas is most constituent of natural gas used as fuel. So these are physical property. Now let's go to we need to go to chemical property first before we now look at something. Okay, so let's look at chemical properties of alkane. Let me launch my board. Chemical properties of alkane. Let's look at chemical properties of alkane now. Chemical properties of alkane. Chemical properties of alkane. Alkane has two major chemical properties. Number one is called combustion. Combustion reaction. Now, what happens in combustion reaction? A process by alkane reacts with oxygen to give you carbon dioxide plus water. Now, let's use methane as an example now. You know, methane is a member of alkane. So if you use CH4 plus oxygen, you get carbon dioxide. This is the formula for carbon dioxide. And then you get water. You get water, H2O. So the equation may not be balanced, but you can go ahead and balance it. Now let's try and balance this equation. The carbon here, the hydrogen here is also, you can put 2 here. Now the oxygen here is 2, the oxygen here is 2. That means for oxygen, so you can put 2 here. So if we do like this, it's balanced. So this is called combustion reaction. Now, after combustion reaction, we have a substitution reaction. Substitution reaction. What do we mean by substitution reaction? Now, this is when a member of alkane exchange its hydrogen with another atom. Okay, an alkane molecule, the hydrogen is replaced by another atom. Now, usually by halogens. At this point, you should know what I mean by halogens. Halogens are group 7 elements: chlorine, bromine, iodine. Mostly, these are the ones we use. Now, if we now have hydrocarbon like, say, CH4, this is methane, and then chlorine, it reacts with chlorine. Now, what will happen here is that these two chlorine will replace 2 hydrogen here. So we now have CH2, 2 hydrogen will be gone, and then the remaining, to balance it up, we'll put 2 chlorine. All right, so this is what you get. You get 1,2-dichloromethane. How do I know? If you draw it, you will know. Now let's draw it. Carbon is 1. There is hydrogen here. There is hydrogen here. Okay. Then we now have chlorine and chlorine. Okay. Now this is dichloromethane. There's no need to put 1, 2. Or you just say 1,1-dichloromethane. 1,1-dichloromethane. So it is easier to name when you have drawn. Why do we say 1,1? Because the carbon is 1 and the chlorine is attached to carbon 1. And how many chlorine do we have there? You have 2 chlorine, that's why we say dichloro. And then it's from a member of alkane called methane. So this is a 1,1-dichloromethane. So these are the two major reactions of alkane. So we use methane as a case study. So combustion reaction and substitution reaction. There is it, substitution reaction, number 2. However, there are phenomena you need to know as well. We have what is called cracking, number 3. You can also cite this one as a reaction. Okay. Cracking. Now, what is cracking? Cracking is when long chain hydrocarbon. When I say long chain hydrocarbon, the chain can be as long as 10 or more than 10. C10H22. Long chain hydrocarbon is broken down into smaller chain hydrocarbon. Now, when long chain hydrocarbon is broken down into smaller chain hydrocarbon, you get, you know what this is? C2H4, 18 from the family of alkane. You get 18 molecule, and then you get alkane molecule. So let's take 2 away from 10. That gives you C8. Take 4 away from 22. That gives you H18. So hydrocarbon with 8 carbon. Hydrocarbon with 8 carbon. What's the name of that? That's the octane, from the word octave. Octane. So cracking is when what? Long chain hydrocarbon is broken down into smaller chain hydrocarbon. And in the process, 18 is always given out. Okay. Now, cracking can be catalytic. Catalytic is when catalyst is used, or B, it can be thermal. Thermal is when heat is used. Now, examiner usually asks this question: what is the difference between cracking and reforming? This is not a property of alkane, but it's a term that you must reforming. What is the difference between cracking and reforming? Now, reforming is just when hydrocarbon is rearranged for better quality. You rearrange the structure of hydrocarbon. Okay, now let's say the chain of hydrocarbon is long, you can change it to branch chain, or you can change branch chain to long chain. So reforming is simply when the structure of hydrocarbon is rearranged either to branch chain or to straight chain just to improve quality. So reforming has to do with quality, while catalytic has to do with quantity and quality. Now, whenever we do cracking for crude oil, cracking for petrol, we want to increase the production, we want to increase the quantity. So cracking make the production, the quantity to be more. While reforming simply improve the quality. So if you ask me, a reformed petrol, it should be the best option to go for quality. So reforming, it is the restructuring of long chain to branch chain. It can be vice versa. So we are done with what now? With the reaction of what? Of alkane. Okay, like I said, I don't want this video to be too long. We also have alkane. Just as we have discussed alkane, we have the members of alkane, we have the reactions of alkane. Okay, before we now go to alcohol. Now let's quickly look at alkane, members of alkane and reactions of alkane before we end the class. Let's look at alkane now. Alkane before we end the class. Now these are alkanes. They follow this pattern. Alkane follow this pattern. This general formula CnH2n. So if you want to get first member, make your N to be 1 and you get your first member. However, one carbon member does not exist in alkane, does not exist. So we start with 2 members. We have ethane, okay? We have propene. So that starts with 2 when N equals to 2. Propene when N equals to 3, like that. Okay, so next, this is how you draw the structure of ethane. You see, this is double bond. That's double bond. Okay, that's double bond. The double bond shows that it is ENE, another family, which is alkane family. But because the carbon is so, we call it ethane. So this is ethane. Why this is propane? Why do you call it propane? Because the carbon is 3. 1, 2, and 3. Don't mind my marker. It's not writing very well. 1, 2, and 3. And 3. Okay, so now a very good reaction I want us to put in mind: additional reaction. Ethane undergo additional reaction. Take note of this. Now, when alkane, the first one we mentioned was alkane. It undergo substitution reaction, but this one undergo addition reaction. What is addition reaction? When an alkene member ENE reacts with halogens or another atom, thereby opening up its double bond, converting the double bond to single. So you see, it has double bond here. After reaction, the double bond turns to single. Okay, it is not replacement of hydrogen, but bromine is added to the bond. The hydrogen is still 1, 2, 3, 4. In alkane, the hydrogen reduced, but in alkene, ENE, in alkane, the hydrogen still maintains its number 1, 2, 3, 4. But it has bromine atom in addition, so we call it additional reaction. Now, additional reaction of ethene with bromine, you will always notice that when that reaction happens, the bromine will change from brown color to colorless. So that is the confirmation test for double bond. Double bond are called unsaturated hydrocarbon because they have more than one bond, and you can always confirm them when you react them with bromine water that is reddish brown. It will turn bromine water from reddish brown to colorless. When that happens, you know that it is a double bond hydrocarbon or triple bond hydrocarbon. Now, to differentiate double bond from triple bond, a further reaction needs to be taken. Okay, all right. So addition reaction. Now, addition reaction again. When ethene reacts with hydrogen, it forms ethane. So you can form ethane from ethene. It's just a reaction with hydrogen. That's another reaction. Okay, now there is another one that is not included in this slide. Let me quickly show you that. That is reaction of alkane with steam. Steam is gaseous state of water. When this happens, you get alcohol. That's the formation of alcohol. Reaction of alkane with steam will give you alcohol. Now, this reaction needs to happen under a specified condition. So what are the conditions now? Under a specified condition. What are the conditions? Just so down right here. Okay. Now the conditions are for you to form alcohol from alkene, from double bond. The condition has to be number 1, high temperature of 300 atm. I'm sorry, 300 degree, not 18. 300 degree, high temperature of 300 degrees centigrade. 300 degree centigrade. Number two, pressure of 65 atm. Atm means atmosphere. That's the unit for pressure. And number three, it has to be at the presence of a particular catalyst called phosphoric acid, H3PO4. Phosphoric acid, phosphoric acid. Now, because I said I don't want the video to be too long, we have looked at sources of hydrocarbon, which is example is crude oil and natural gas. We have looked at alkane. We have looked at some terminology, homologous series, double bond, single bond. We'll look at reactions of alkane, members of alkane. So we're going to end the class here. Please feel free on the comment section to ask any question you want to ask. Okay, you can as well let's book for one-on-one class. Give me your time. I will make the arrangement possible from my end. Okay, so ask question from the comment section. I will answer you. Cat 2 exam is Wednesday. This class will be very, very, very beneficial for you to pass Cat 2 test and the handout material that I sent on same. So for now, Bori, enjoy the rest of your day. Bye bye.